Hello, welcome back students. So today we will be learning about the interrupts in 8051 microcontroller. Okay, so what is an interrupt? First of all, what is an interrupt? It is a subroutine calls that is given by the microcontroller when some other program with high priority is requested for acquiring the system buses. Then interrupt occur in a current running program. Okay, so what is an interrupter? For example, this is a CPU, okay, and it is performing, and right now it is performing 2 plus 2. Okay, it is just an example. Okay, so when it is performing 2 plus 2 or operation, then an interrupt occur, and this interrupt says perform the instruction 2 into 3. So for current duration of time, this CPU will leave this operation. Okay, it will not perform this operation. It will pause this operation or postpone this operation, and it will take this operation first. This was CPU. Okay, because it is an interrupt, it has a higher priority than whatever the CPU is processing right now. So it will perform 2 into 3, which is 6. When this instruction is over, then it will come back to its previous operation, which was 2 plus 2, and start performing that operation. Okay, so that's what I have written here, that interrupts provide a method to postpone or delay the current process. As I've told you, CPU was performing 2 into T, 2 into 2, and an interrupt occur which says 2 into 3. So the method to postpone or delay the current process. So it postpones this process which is it was performing currently and performs the subroutine task. Subroutine task was this interrupt, okay, which was 2 into 3, and it performs this task and completes this task, and then restart the standard program again, and then it restarts this standard program again which it was performing earlier. So there are 5 types of interrupt, as I have told you in the block diagram of 8051 microcontroller. There are 5 types of interrupt. As you can see, two were the external interrupt and three were the internal interrupts. Same I have explained there, that there are 5 types of interrupt. First one is timer 0 overflow interrupt, external hardware interrupt, timer 1 overflow interrupt, external hardware interrupt INT1, and serial communication interrupt. So this, they both are external interrupts, and these ones are timer interrupts. So if you remember, what was timer or counter used for? Counter. Timer was used to delay the process, and counter was used to count the external events which was going outside the microprocessor controller. And the serial communication, I have told you, there was also a block known as serial communication block, as you can see here in the block diagram, this serial port. Okay, so this generates one of the output, sorry, interrupt. And what was its job? Its job was to serial port. It includes on-chip serial port. Okay, sorry. So serial, whenever we are transferring data, so its job was simply that whenever we were transferring the data from transmission to receiver end, it was in like it was in, first of all, it was in serial mode. Then we will because of serial port, it will make it parallel, and when it is parallel, with the help of serial port, we will make it series. Okay, this was the work of serial port. So let's skip the serial port. Now we have studied the types of microcontroller, sorry, types of interrupts of microcontroller. Okay, now let's see more about interrupts. Okay, so interrupt structure of 8051 microcontroller. After reset, as we have studied in the architect pin description of 8051, there was a pin reset. Okay, so whenever we switch on this pin, the microcontroller go back to it initial values. Okay, like as it was new. You all know what is the meaning of reset. Okay, so that is what happening when we are pressing that key. After reset, all the interrupts get disabled, and therefore all the interrupts is enabled by software. Okay, so whenever we press this reset key, then all the values are back to the initial, which means all the interrupts are disabled, and with the help of software we will enable each interrupt one by one or all at once. Okay, with the use of software, it is in programming section. So for all the 5 interrupts, if any of all interrupts are activated, any one or all, it's up to us that we have to enable 2 interrupts, 3 interrupts, or all of the interrupts. Okay, with programming we can do that. So yes, this will set the corresponding interrupt flag as representation as represent in the figure which corresponds to interrupt structure of 8051 microcontroller. Yes, we will see figure just a little. Uh, just we will see the figure just a moment. Okay, first let me explain you this uh, interrupt structure. So interrupt structure consists of interrupt enable register and interrupt priority register. Okay, so this table is interrupt vector table. Okay, so as I have told you, there were 5 types of interrupt: 0 to 4. Whenever interrupt number is 0, the external int0 interrupt is enabled. Okay, and its address is 0003h. H is for hexadecimal. And whenever interrupt number is 1, it is timer counter 0. Whenever it is 2, it is external int1. Whenever it is 3, it is timer counter 1. And whenever it is 4, it is serial communication. And these all are the address of those interrupt. Okay, now let's see the diagram, or the see what is this. This is the inside of interrupt control. And what was interrupt control? For that, let's see the diagram, sorry, the block diagram of 8051. See, this was interrupt control. Okay, now we will study the insides of interrupt control. So let's go. Yes, so inside this insides of interrupt control consist of interrupts, some external and some internal. IE register, which I have told you was interrupt enable register, and IP register, which I have told you was interrupt priority register. Okay, yes. So what are they doing? Let's study what are they doing. So when IE is 1, it means enable. And how much interrupts we have to enable? We have to program this thing. Okay, to let the interrupt control know how much keys we have to enable, or how much interrupt we have to enable at one. And when IE is 0, it means disable the interrupt. Okay, so we have a choice that, okay, this, as you can see, these keys, through these keys we can decide which interrupt we have to enable or disable. Like it is int 0 f tf0 int 1 tf1, or this is serial communication interrupt. Okay, yes. So with this, see, as the name suggests, individual interrupt enable. With these keys we can decide which interrupt we have to send to the interrupt priority register. And with these keys we enable all at once. Like if you want to send only 2 interrupts, like int t0 and tf0, then we will enable only these 2 keys. Okay, and all other keys will be disabled. Then we will not use this one, these keys. And if we have to send every key, every interrupt, then instead of enabling every single interrupt one by one, we will just use this global enable, which will enable all the keys, and all the interrupts will go to IP register. So when all the interrupts are moved forward to IP register, which means interrupt priority register, this block will decide which interrupt has the highest priority. Okay, it is also done through coding and programming, so we do not have to understand how it will, define which is the highest priority, which has the highest priority, which has the smallest priority. Okay, so we don't have to worry about it. We just have to know that IE register decides which interrupt has the highest priority. So whichever interrupt will be having the highest priority, it will send it to the CPU. See, highest priority will have sent to the CPU. Let me show you the block diagram. Highest priority interrupt has been, see, like this. In interrupt control, where we have sent all the 5 interrupts at one. IP register decides the highest priority interrupt, and then that interrupt is sent to CPU, and then CPU works according to that interrupt. And when that instruction has been fulfilled, then the second highest priority interrupt will go, then the third, then the fourth, and then the fifth, likewise. Okay, so now let's move to our diagram. So yes, this was the this is what is inside interrupt control. So let's have a quick review. Sorry, revision. So what was interrupt? Interrupt was whenever CPU is performing something and there is a high priority instruction coming from an interrupt request, then it will stop this instruction for a while or delay it and perform the another instruction that was interrupted. And then when this is performed, it will come back to its previous instruction that it was performing. There are five kinds of interrupt: timer 0, external, timer 1, external, and serial communication interrupt. And we have learned about the interrupt, how to uh, uh, in the structure which is inside the interrupt, which is interrupt enable register, interrupt priority register. We have learned about interrupt vector table, and we have learned about the working of the interrupt control, which is this. The interrupts are sent to IE register, which is interrupt enable register. It enables all the interrupts at once or one by one, and the work of IP register is to uh, to arrange the interrupts according to their priorities and then send them to CPU for the further process. So that's it for today's video. Thank you for watching.